Today I'll be testing my skills at the Math Dojo PSLE edition. So here we have numbers, okay, and geometry, and the last one is statistics, okay. So I'm gonna go with geometry. Okay, so we're here at this nice dojo. Okay, I'm ready to give it a go. So the first question is about finding angles. Okay, ABCD is a trapezium, DEF is a rhombus. You have two angles and I want to find ADE, the green angle. So in a trapezium, we know that two adjacent angles add up to 180 degrees. So we can probably find ADC quite easily, right? Yeah, just 180 degrees minus 100 degrees giving you 80 degrees. And for BCD, 180 degrees minus 108 degrees giving us 72 degrees. Okay, now let's use the fact that DEFC is a rhombus and rhombus has all sides equal. Okay, so then DEC is an isosceles triangle, meaning DEC equals to DECE equals to 72 degrees. Now we can find EDC. EDC is 180 degrees minus these two angles, and that gives us 36 degrees. And now we can find ADE, it's ADC minus EDC, AT minus 36 degrees, 44 degrees. Okay, nice. Do we get to go to level 2 now? Nope. Seems like there's more. So GHI is a right angled triangle and I want to find GHI. Okay, so I see this cross over here, which means that these two angles are equal, right? Because of vertically opposite angles. So I need to find DGE first. And I can take 180 degrees minus GDE, which is 44 degrees, minus DEG, which is 180 minus 72 degrees. And we see that DGE is 28 degrees, which means that I can now find that GHI. Yeah, because I know two angles, I can just take 180 degrees minus 28 degrees minus 90 degrees, and that should give us the answer. 62 degrees. Is it right? Okay, it's right. Okay, so 2 questions down, and ooh, seems like we're on to the next level. This level seems harder. Okay, so we have ABCD, BFG, and CGHI. They are squares, and then we have rhombuses BCKJ and BJLG. So first we can find the areas of the square, right? There's 5 cm, 12 cm, so I'm just gonna go ahead and do that first. So we have 25 centimeters square, 25 square centimeters and 144 square centimeters. Now, then this is a rhombus, BCKJ is a rhombus, and it shares the same base, the same height as the square. So we can say that this rhombus has the same area, right? And I think for the bigger square, it also shares the same area as the rhombus, BJLG. Okay, now what? The question also says that BJ is equal to CG, which means it's also the same as all the other sides of the square. So now we can see that this has the same base as this, and it also has the same height, which means that this area is the same as this area over there. Area of BJLG is also the same as this area. So we basically just add up the two areas, and that gives us 169 square centimeters. Ha, looks like I got that right. Okay, I'm not done yet. ABCD is a square and BFG is a rectangle. Find the length of FE. Okay, so first thing that I notice is that GBC is half of ABCD. And that means we can find GBC quite easily. We just need to find the area of ABCD and then halve it. Does this help with finding FE though? Oh wait, I've just realized that GBC is also half of the rectangle. That means we can find the area of the rectangle by multiplying a GBC by 2. Okay, basically it means that square ABCD and triangle BFC are the same. Now we just need to find the length of FE by dividing by the width, giving us 12.5 cm. Okay, and she's quick to tell us there's another question. Okay, here we have an equilateral triangle, so that means that all sides are the same. I'm gonna just write that down first. We also know E is the midpoint of AC, so AE equals to EC. And the last thing we have from the question is that DE is twice as long as EB, so if DE is 2 units, EB is 1 unit. Now I'm gonna look for triangles with the same base and same height. Oh, I've got one. DEC and AED share the same height and same base. So it means that they have the same area. So now we know AED, and it looks like it also shares the same height with the area we want. But the bases are different. One of them is twice as long as the other. Doesn't that mean that one area is twice as large as the other? To find AEB, I just need to divide 70 by 2, giving 35 square centimeters. Oh great, I'm moving up the next level. Yay. Ooh, what do we have here? So he's been expecting me. And I guess I need to be creative for this level. Oh, this question, I think I've seen it online. So there's a plot of land with an area. So I need to find AB, length of AB, and then the perimeter of the plot of land. But all we know is the total length of the fence, and we don't know any of the smaller lengths here. I'm going to try rearranging and moving the lengths to the outside to fill it up. And this looks really useful. Now we can take the total length of the fence and subtract from it the perimeter of the rectangle. And the result is 2 of these lengths. So now let's compute the numbers. And that gives us 15 meters. So AB is 25 meters. Great. But we're not done yet. Still have to find the perimeter. The easiest way to do this is probably to get the length of fence and subtract from it the 2 shortest side. But how do we find that? One thing the question says is that each rectangular portion has the same width. So we can take 36 meters divided by 3 to get the width of one plot. Oh, and now we can find the area of the top and bottom plot. So the plot here is 12 meters times 25 meters. And the plot here is 12 meters times 27 meters. And now we can find the area of the shortest plot by subtracting the top and bottom from the total. And now we can find the shortest length. We can take the area divided by 12 meters, giving us 21 meters. So now we can take the total length of fence, and then we minus 2 of 21 meters, and that gives us 134 meters. And looks like it's right. Are there any more questions? Oh no, looks like we're not done. Here we have a windmill shape cut up from a square piece of paper. Each side seems to be 15 centimeters. And similar to the previous question, we only know the perimeter of the total figure. So could we try rearranging again? I'm going to try moving all of it to the edges so they fill up the square. And we're left with 8 of these lengths. So the perimeter was 108 cm. And we saw that all of the lengths could be filled up to 60 cm. And we know that because 15 cm times 4 is 60 cm. Subtracting this from the total perimeter, we get 48 centimeters, and there are 8 pieces, so each piece is 6 centimeters. But the question wants x, right? So that's 6 cm plus 3 cm giving us 9 cm. Okay, bring on the next one. Oh, there's 2 more. Okay, so here we have a semicircle, a large one and 3 smaller ones. Okay. Diameter of the large semicircle is 4 times as long as the small one, and we want to find the total area of the figure. So if this is anything like the previous questions, then we probably need to rearrange things somehow. Right? What can we do here? Perhaps you could, move everything to one side like this. And this works, right? We can add this up to get 12 cm, add this up to get 7 cm, and take 12 minus 7 to get the length of one small semicircle. And to find one large semicircle, we just multiply by 4. Now we can use pi r squared to find the area of the figure. Now I just need to add 3 small semicircles and 1 large semicircle. Keeping in mind that one semicircle is half pi r squared. Now I calculate, giving my answer in 2 significant figures. Finally, we're at the last question of level 3. So here is a figure with 4 squares and one portion is shaded. We know that AE equals EF. So that means E is the midpoint, dividing the top 2 squares into 4 equal parts. And now I can see that this triangle has the same base and height as this triangle over here, so I'm just gonna move it over. Okay, I think I'm getting closer to the answer. I'll cut the bottom 2 squares by half as well, bringing the total figure to 8 units. And we can also see that this triangle is half of the square, so we can make that a little clearer by moving this here. Oh, and this triangle is half of these 3 rectangles, so I'm going to cut it into half and move this part over here. Now I count the shaded squares. So that gives me 7 over 16. Yay! Okay, is he being nice? Oh, not really. But finally we're on to the last level. Hello. A different dimension? Ah, I see. So here we have a figure with 8 cubes, and we want to find the number of cubes with exactly 4 sides painted blue, so not 5, not 6. So I want to be trying to turn the figure around in my head. Okay, now let's look at this cube. It has 1, 2, 3, 4, 5. So nope, it doesn't count. So this one, 1, 2, 3, 4. Okay, that's our first one. And there's one at the back here. So 1, 2, 3, 4. Yeah, 4 sides. So that's 2. And the one in front here, 1, 2, 3, 4. That also counts. And so that's this one, 1, 2, 3, 4. One over here is the same as the other one, so yes. And the one over here, 1, 2, 3, 4, also 4 sides. The last one doesn't count because it has 5 sides painted. On to the next. Okay, so I use 1 cm cubes to form a cuboid. And then I want to find how many cubes only have 2 faces painted. So what would this cuboid look like? So there will be 10 on this side, 15 on this side, and 30 on this side, right? So then we have a cuboid and we are painting it. So I think the ones here only have 1 side painted. The ones at the corner have 3 sides painted. So the ones with 2 sides painted are only the ones here. And how many of them are there? Counting along the length, we have 15 minus 2, so that's 13 cubes. 4 of these cubes, 1, 2, 3, 4, so 52. Along the width, we have 10 minus 2, giving us 8 cubes, and 4 of them giving 32. And along the height, we have 30 minus 2, that's 28, and then 28 times 4, 112. Now we add everything together. Okay, final question. Okay, a stone block was painted green, and then a figure was cut from it, and this figure can be divided into 6 identical cubes. We know the total area of the unpainted surface, and we want to find the volume of the original stone block. I think we should start from finding the number of unpainted surfaces. On this side, there's exactly 2 squares unpainted. If we imagine turning it around, then this part is a little trickier. The sides here may not add up to 1 square exactly, but combined, they add up to 2 squares. So that's 4 squares so far, and on the other side we have 2 more, so the total is 6. And now we can take 150 divided by 6 to find each area. And now we square root this to find the length. And the question wants the volume of the original stone block. So that's length times width times height, giving us 1125. And we're done. Do I get some kind of prize? Geometry Master. Okay, nice. That was fun but also tiring, and I think I'll try numbers and statistics next time.